So today we are back to fix another problem with a 3D design and 3D printing solution. So what is the problem today? Today I simply need to display these headphones in another video. Now I could have just held them out and spun them around in my hand, but since I have the technology, I set out to make a more professional looking solution. So unfortunately I had some settings or something change in my OBS recording software, so my microphone did not record through my design process properly. So now I take this as a challenge to try a new style and format for this type of video. Let me know if you like it any more or less than previous videos. So instead of having active commentary, I will be narrating instead. Let's begin. We of course start with the sketch viewing from the top plane. My plan is to try and make a simple stand that can be printed flat on the bed, rather than vertically like you would normally think. After the sketch is created, I need to make some parameters. I start with main body thickness. I have a hard time deciding what the right thickness for the profile of the object should be as I eyeball the thickness using my calipers. I debate between a thickness of between 6 and 10 millimeters, but eventually I land on 6 millimeters to start with. Next I measure the headphone's cup height, which comes to about 112 millimeters. After that I measure the height of the headband of my headphones. This comes to roughly 105 millimeters. I note in the video that the headphone's cup and band somewhat overlap each other, but I was fine with this detail and not very picky about correcting it, since it would just mean some extra fit tolerance space for the area around it on the stand. I almost start working on the actual sketch, but try to get all of the measurements out of the way at the start here, so I continue making measurements. Now I make the parameter for headphone depth. This is for the largest depth of the headphones looking at them from the side. Well, width if you're looking at it from the side. Which on this model is the swivel hooks connecting the band to the outside of the cups. So I measure from those points, getting 95 millimeters. And for my final measurement, I get the headphone band depth. This will get the width of the headphone band, so I know how much room to put in the holder's hook to actually hold the headphones, which this comes to roughly 53.5 millimeters. After making these parameters, I start to finally work on the main body, though soon after I need to make more parameters again. So I make a parameter called stability fit tolerance, which I made equal 10 millimeters. This is to give areas where the headphones need to actually fit some extra room, generally speaking, to fit. Then I add this and multiply it by 2 to the length of my initial drawing so far, making the string headphones depth plus, in parentheses, stability fit tolerance $2, or multiplied by 2. This makes it so that the total desired fit tolerance is calculated first, then added to the headphones depth parameter. I then continue to draw the basic shape of the stand. The string for the main backbone that I started calling the stem is headphone cup height plus headphone band height plus stability fit tolerance. This adds the two measured parts of the headphones together, resulting in a decent chunk of natural fit tolerance since I didn't bother accounting for the overlap that the two pieces had on each other. That is also why I only added one fit tolerance parameter. I wanted to include it for good measure, but not completely overdo the fit tolerance. Then I continued to add the outer border lines for the body, adding the body thickness parameter between them. But since I started drawing and looking at the thickness compared to the height of the part, I started thinking that the thickness wasn't going to be enough. But this is why we use these parameters. I went into the parameters table and changed the value of main body thickness from 6 to 8 millimeters and was satisfied with that thickness for the time being. The next line is the hook that holds the headphones, so the string is headband depth plus stability fit tolerance. Again, I only added one fit tolerance because I simply didn't want to overdo the amount of extra space the headphones would have to move around on the hook. Before going on to the next line, I realized that something was going to be off. I go back into the string of the main hook line and add plus main body thickness to it. This is so that the line ends at the proper point to allow the actual hook part on the hook to be created, at least also in the proper place. Next, I realized that I never actually got the thickness of the headband to know the proper depth needed of the hook. So I take my measurement and make the parameter. Headphone band thickness, which comes to around 15 millimeters. To try and avoid issues with the drawing in the future, I try to shorten the length of the outer line created already, though I have issues with the snapping and getting it aligned properly. To fix this, I simply draw a line across the inner line where the outer line should meet it, then extended the outer line to meet with the new alignment line. After getting the right joints, I make the alignment line a construction line with the hotkey of X. This will make it so that the alignment line won't cut off the part into different pieces and cause an interruption in the extrusion process. This is just a small but useful detail. Now I continue working on the hook. The string I start with for the outer hook is headphone band thickness, then add the top of the hook and give it the main body thickness parameter. I try to continue with the drawing, but it just looks weird as I try to draw it out. Then I realize I need to go back into the string and add main body thickness to the outer line to get the right height. Continuing on, I add the inner line of the hook and give it the headphone band thickness parameter. After that, I draw a line to match where the outer line ends without adding a parameter because it should take care of itself. Next, I tried closing off the diagram with what I had already made, but really though, something didn't look right. And I guess I would be right. I delete what I had just drew and started working from the outer line, giving this new line a string of main body thickness plus headphone band thickness, then closed off the drawing since the lines lined up with what had already been created. Now we are ready to actually make a physical part, except for one thing. We don't have an actual thickness for the body defined yet. So I go into the parameter menu once more and make a new one called main body width. From there I had to think about how I actually wanted this to go down. The problem with how I wanted to do this model is that there would only be one depth for the whole part, at least logistically. So I needed to make a width that is wide enough to support and stand properly without tipping over, while making a hook thin enough that it can logically cradle the headphones. The way that I decided to get my rough measurement was to measure between the plastic cups of my headphones. For those following along making their own model, this works for me because the cups bend inwards. For many average headphones, this is not the case, however. For average headphones, I suggest using your calipers or whatever other measurement tool to estimate the thickness of your part's body compared to how far you are willing to let your headphones float if you don't plan on adding any rounding to your hook. If you do add rounding to the inner edges of your hook, this can supplement this issue a bit and make your headphones fit on the stand better and rest on the post more naturally. Or if you make it a really rounded cylindrical hook, you may not even have to worry about this at all. The downside is that you probably will have to be more mindful of your printing orientation, or you may need supports depending on how steep the rounding is. But more than likely you can get away with just properly keeping in mind your print orientation while designing your model. I have some issues later on in this video because toward the end of designing, I stopped thinking about the print orientation and was only looking at the aesthetics of the model. Anyway, I got a rough measurement of 29mm and then I was ready to extrude. I apply the parameter to the function box and try to examine the model. However, I spend a long time just trying to get the camera to rotate the model properly to the angle that I want to view it at, but also fail miserably. After extruding, I'm kind of dissatisfied with the plain and beginner-looking nature of it and decide to expand and stabilize the model. What I want to do is make brackets on the inner corners of the stand. I want them to be at 45 degrees in angle and a certain distance measured away from the inner corner. To accomplish this, I make a line close to the corner and give it a constraint of 45 degrees. Then attach it to the other wall inside of the part. After doing that on the other side as well, I make them both construction lines. These are only example lines to get the proper angle in the proper places. They may not have been necessary if I had just used the coincident constraint on the ends of the usable line that we're going to make and added the angle parameter, but this is how I did it for now. I made a line between the two inner corner walls, not caring about anything other than the two wall lines were selected as the start and end points. Then, to get the proper angle, I used the parallel constraint on the usable line and the small example line I created before. This method makes it so that the coincident constraints are already created at the angle and will match your example line. I repeat this on the top side of the model. Now I can simply add a dimension between the usable line and the point of the inner corner. However, before doing so, I want to make a parameter for this action. This one is called headphone holder bracket length, and I give it a value of 50 millimeters to start with. So I apply the dimension, and it basically comes right to the edge of the hook. So I end up removing the length dimension and manually linking the point of the bracket with the end of the hook. Continuing on, I make another line inside the usable line geometry. Again, making sure to select the walls as the start and end points, but not caring about any of the other dimensions right now. Then I add the parallel parameter again to make sure it's parallel with our outer usable line. Then putting the main body thickness dimension between the two usable lines to give it its proper thickness. Then I sat and looked at the model for a bit, still thinking that the bracket looked too plain and featureless. So my plan is to fill it up with more struts. This will give it a little more to look at and give it a bit more stability within the bracket as well. It more than likely won't need the stability, but it won't hurt it to have it either. To get everything in the right place, I start with a line from the inner corner to the center point of the inner usable line and make it a construction line. Then I make two lines on each side of that construction line, again only caring about the start and end points. Once they're created, I make them both parallel with the center construction line and add the main body thickness dimension between the outer lines. And finally, to get them centered, I put another dimension between one of the outer lines and the center line and give it a string of main body thickness divided by 2. This is one of the easiest ways I have found to center geometry other than using the center point when applicable. Then I repeat this process for the centers on the remaining triangle areas within our bracket here. After that process is complete, I move on to doing the whole assembly again on the bottom, but this time actually using the parameter which is named base bracket distance with a value of 20 millimeters. I also remove the other bracket parameter since I won't be needing it anymore. I'm worried about the size of this bracket because it does have the potential to be getting in the way of the headphones as they hang from the hook if the bracket is too large. So I tried to be conservative with its size while also trying to make it big enough to hopefully make a supportive impact to the integrity of the stem. Another small change is that I drew the second usable line on the outside of the first one because I wanted the 20 millimeters to be the actual inner space of the inside of this bracket, and the space is more of a concern on this one, unlike the last. The last bracket size was less important because the width and the height of the headphones band should be able to reach around it without problem, most of the time at least. While the bottom is where the bulkier cups and padding on basically every headphone model are. So I also only make one inner strut on this bracket because of its significantly smaller size. After this is complete, I have to go into the working timeline and redefine the extrusion of the main body to include the brackets. And while doing so, I once again have difficulty with the camera/object rotation as I try to examine the part. So after that, once again, I am not fully satisfied with the looks of my part here. So I go back into the sketch and add some fillets to the corners of the hook, spokes, or whatever you want to call them. To get them evenly rounded, I use the string main body width divided by 2 on both of the corners. To apply this to your designs, you just use the value of your width between the two corners divided by 2. This should result in a perfectly even rounding if the right value is used. However, this was soon scrapped because I liked the look and the logic of just rounding the outer corners of the spokes instead. So instead of adding the divided by 2, you just have the value of the thickness between the two corners, and you should get a perfect rounding up to the corner and the other surface. I decided to do this for 2 reasons as stated before. 1, I liked the way it looked better, and 2, I wanted the full height of the spokes on the inner edges to ensure that the headphones band is securely stored and cradled within the hook. Then I also applied the same rounding to the upper side of the base of the stand, but this was how I originally planned on doing this rounding for this section. Now here is a major divergence from my original plan. I should have been done here, but as I examined the model, I still worried about the stability and tippability of the model. I worried that the model wouldn't work or simply would be poorly rated on MakerWorld, where I plan to post this along with basically all my other models that I make on these videos. So as a contingency plan, I decided to make an alternate version. I copied the model and renamed the current one to Headphone Holder V-Base, and the other one to Headphone Holder Basic. I start working on our new model by removing the original base. To do this and properly implement the new base, I go back into the sketch and add a little line between the top of the bottom corner and the outer wall of the stem. This makes a separation of the original sketched base and the rest of the body, and the program automatically removes it because of this. But I still have to go into the extrusion on the timeline and remove the bracket now. This leaves the bottom as a blank slate for our new base. I continue on by making a new sketch and selecting the bottom as the plane for it to work off of. I project the existing front and back geometry of the stem to get some baseline geometries to work off of. Using the back points as a starting point, I make a line off of them using the string start parentheses, stability fit tolerance times 2, and parentheses plus headphone depth. And while in the placement menu, to make the angle placement easier, I applied a 45-degree angle constraint on the line. Then I mentioned that I plan to simply mirror this half of the drawing to the other side. So I find the middle point of the projected lines and draw a line straight up to an extended but unimportant length and make it a construction line. Then I added the end cap to the end of our actual drawn line and made its length the main body thickness. After that, I simply tried to close the sketch, but it didn't look right to me, and it really wasn't. To start with, I changed the length of the end cap to the main body width, making it significantly wider. Then I drew an extended line that went to the length of the inner project line. This was to make an easy intersection to complete the sketch after mirroring. So now that with the leg basically complete, the only thing left to do is to mirror it. So I select all three of our created lines, bring up the mirror creation tool, and select the construction center line as the mirror line, making it an essentially perfect join other than the middle lines being overcompensated. To fix this, I take the original overcompensated line's end and pull it toward the center to try to get them to connect together properly. However, I couldn't really get this to work by simple dragging. But the solution to this problem was even simpler. I clicked on the original endpoint and used the coincident constraint on it and the center construction line, and that made a perfect join. And all of that was so that I could round that center corner of the V stand. I made a new constraint called base inner V rounding and gave it a starting value of 25 millimeters. I applied the fillet in the sketch and extruded the base by the main body thickness value. I tried to examine the model, but again was struggling with the camera. Eventually I got to a place where I was satisfied enough to look at the base. I decided to open up the parameter menu and experiment with the rounding. However, I noticed that nothing was happening as I was changing the value. But I also wasn't getting any errors for some reason either. So something was clearly not working right, and the solution was pretty readily apparent to me, and so I went back into the base sketch and looked at the rounding's function string, and it was just 25, rather than the parameter name. Looking back, I do think I just forgot to apply the parameter after applying the rounding and making the parameter. Just a simple slip of the mind, unfortunately. So I updated this and ran into another new issue. The rounding was now uneven due to the difference in the rounding size, and the rounding causing the dimension parameter lock to be deleted. But this solution was as simple as the last sketching problem. I selected the fillet control point and used the coincident constraint on it and the center line again, which fixed the issue. So I continue now with the rounding experimenting. I tried a small variety of values and landed on 15 millimeters. After that, I add the rounding to the ends of the base's end caps using the modify tool this time because the sketch's perspective simply doesn't accommodate doing it in the sketch this time. Then I get really crazy and start seeing how far I can take the rounding, so I added it to the whole inner side of the base and the cap edges, and don't hate what I see as a result, honestly. But then I go even farther, applying rounding to the inner stem under the bracket and the inner spoke of the hook. I tried various values but didn't like the looks of the small rounding, so I tried the main body thickness parameter and that didn't work either, which was a little strange to me based on my knowledge. The whole model was extruded by this thickness, so it shouldn't be an issue. So I try a tiny bit smaller with values like 7.8 millimeters and actually have no issues with that. I discovered that 7.9 is as big as the fillets can get because for some reason there's just that 0.1 millimeters lost on the bracket. I would assume this is because of something to do with the angling, but it's not a big deal to me and I just use it and continue on. Then I save the model and go through the process of making that model read-only and the original model editable. I have to do this because I am on the free version of Fusion 360 and am at my 10 editable document limit. I go back to the original model and add the same rounding to maintain continuity between the two models. The first rounding I go to apply is up the whole size of the body except the edges of the hook spoke using the 7.9 millimeters again. But before applying, I examine the model first and don't like the look of the stem of how the stem would turn out. So I change the rounding back to 0 to be able to unselect the geometries. If you know of a way to unselect geometries without having to reset the parameter to 0, let me know. But I do so and unselect the inner stem edges, reapplying the 7.9 rounding to examine the rest of it further now. I am satisfied with this rounding and save the new model. But since I removed the stem rounding on this model, I decided to remove it on the other model to once again maintain the continuity between the two models. But as I look at the V-base model again, especially without the rounding on the stem, I start to dislike the base of the stem being a basic 90-degree angle again. So I decide to experiment with trying to incorporate the base bracket back in again. So I start this process by simply going into the original extrusion of the main body and include the bracket back in it. This leads to some inconsistencies, unfortunately. First of all, the bracket's geometries being included interfere with the full rounding of the base, so that rounding has to be deleted from the working timeline. Next, the base sketch relied on the stem thickness without the bracket being included, but with it included, the base got wider. However, Fusion does have a backup solution for situations like this. Unlike the rounding, which had a red highlighted error in the timeline, this one only has a yellow one. This is because the sketch was referencing geometry that technically isn't there anymore. However, instead of having a meltdown, Fusion just adds a construction line in place of the removed / no longer existing geometry. Since this was the way it is, I just leave it because it wasn't causing any harm really, and I would probably just end up making more issues in the process of trying to fix it. So this error goes effectively ignored. Now we are on to our last issue that adding the bracket added. Because of the V shape, the bracket's bottom wasn't resting on anything. This has an easy enough solution though, as long as I am willing to compromise. Instead of having the deep and small rounded V, I would have to go in the parameter menu and experiment with making the V shallower and the curve much bigger. So I did so. I experimented with enlarging the radius of the fillet until I eventually got to 50 millimeters, which got really close but just a bit too short, then ended on 52 millimeters to have the geometry come just a bit past the bracket end. Next I work on putting the cap and edge rounding back in place. I acknowledged that I couldn't put the rounding the whole way across anymore, but I was hoping that I could just get a little more rounding out of the base. Unfortunately, this just doesn't work, at least with the basic filleting tool. So I compromised again and just added the rounding to the end caps of the base again. Then I decided to add rounding to the bottom bracket to match the top one, which for some reason accepted the full 8 millimeters rather than needing the 7.9. So I save this model and feel that I am finally ready to export and import them into the slicer. I exported both models as step files to start a better habit and to do a small service to the people who download my models. Once I imported one of the models into Bamboo Studio though, I got an error. It stated that the model was too big for the build area, which I hadn't even considered as an issue while designing this model. So I looked up the max build area of the Bamboo Labs P1P, and it was labeled as 256 millimeters in all axes. My model was 258 millimeters tall, 2 millimeters too tall unfortunately. So I had to go back into Fusion 360 and remedy this. I did this by simply going into the main stem dimension and adding -3mm on the end of the string, an extra millimeter of safety cushion. Unfortunately, this fix wasn't as cut and dry as I tried to prepare for. The base of the hook didn't move with the shrinkage of the stem, so I just had to add a dimension between the outer and inner lines of the hook's base and give it a value of the main body thickness parameter. Then this caused one of the spokes to move down with the base of the hook, but the other stood its ground. To level the largest one with the properly sized one, I just drew a line connecting the inner corners of the spokes and used the horizontal vertical constraint on the line. This forced the less constrained bigger spoke down to the properly sized spoke's level. These were the only consistencies, so I saved the model and went through the process of switching the two models' editability again. I then went through the same process on the basic model as the V model. Once I finished that, I save and export both models again and try importing again. But as I imported the first model again, I got the same error, even though the overall height was now 255mm, just under the supposed build volume. However, I did notice this darkened part of the model which displays how the model is crossing over the limits. So I used the in-slicer scaling to scale the size and see how short I actually had to make the model. As a lucky guess, I started with 250mm, and that was right on the money. Even 1mm higher, and it claims the model is too tall. I stated in the video that I do know that you need to consider the rail limitations and the extra height lost from the print head sticking down a bit, but I figured that Bamboo Labs would have accounted for this in their marketing material. Anyway, so now I go back to the process of shortening the models by 9mm instead of simply 3. I don't have to deal with the inconsistencies because they were already fixed now, but I do have to deal with the switching of the editability again to make both of the models the right height, and I have to re-export again. Now with that process done, I import the first model and no error. Okay, cool. Now I have my first model, but I want to try to print both of them at the same time. Can I do it? Yes, I can. The only worry I had was fitting both of them on the build plate, and I was able to achieve that semi-easily. So now I can actually slice and check out the models from that perspective. However, I do immediately notice a small issue after slicing. The side rounding on the basic model meant to print on its side is slightly too steep and would either look a little poopy or need a small bit of supports. I really didn't want to put supports on these models, and for the most part I specifically designed so that they wouldn't need them in this case. However, along the way, I forgot to design for 3D printing and forgot the intended orientation and just focused on the looks. So I bite the bullet and went back into Fusion 360 once more, switched the editability again because of course I ended up on the wrong model, got an ad for malware bytes, and just simply deleted the entire rounding section on the workflow timeline. I then saved, re-exported, and re-imported into the slicer. I forgot to mention that at some point I changed my filament and print profile in Slicer. My normal PLA print profile has no supports usually, but my TPU one does, I guess. So I switched those settings and looked over the model quickly and didn't actually notice anything bad. So I sent the print to my printer. Here is the live footage for that. Okay, so here is mostly all of it printed. However, I did have to stop this print because unfortunately for some reason the nozzle started to constantly get caught on the top here, on the top of the print, and then what would happen, it would cause the thing here, the face of the extruder, I guess, the magnetic face would just pop off, and then it would pause the print, and then it would try and go back into it, and yeah. So it would sit here and get caught and start doing weird stuff. So unfortunately this one is kind of a bust right now. I need to try and print it again, unfortunately, which is a real disappointment because it got like literally 90% of the way through. And the fix, I don't know how to fix this, honestly. I don't know why it's doing that. That's something I would have to look up. But we do have the other one. So it's possible a little bit of rounding would have helped actually on these sides. Only a small bit, not nearly as much as we did. It would help for print removal, so I'll probably add that afterwards. But yeah, I guess we just have to see how this works. Okay, so here is the stand. So now we're just gonna see how this works. Well, there you go. So there are some changes that I can make to make this model a little bit better. I think this is mainly an issue with these headphones because they are simply so big and bulky, but the stand could come out a little bit farther because it's still pushing up against this a bit, which holds it at a slight angle, but that might honestly be helpful in general. But yeah, so this one is basically a success. Now I just need to figure out how I'm going to make the other one work, but that I think comes down more down to the print profile. I don't know yet. I need to look it up and see how this issue happens. It turns out my second computer clip here actually has the audio recorded, but I have already committed to this style, so I'm going to hopefully explain this better here and continue on with the video continuity. So the issue with my version 2 model was that the print head was getting caught on the print, and the face of the extruder would fall off from catching on the print as well and stop the print in its tracks. But why? Well, I am not the first person to have this issue and probably will not be the last. Apparently, and my results can back this up, the problem stems from grid-style infill patterns. Now I was using cubic, but it's less about the actual pattern and more about how the pattern is actually laid while printing. You see, on the grid-style infill, it has to intersect itself pretty often. And instead of avoiding the already printed lines that are there by hopping over or trying to stop the extrusion while going over them, it just simply plows through and keeps building over top of the existing lines. Now, I'm not for sure what the exact issue is here because these infills work for average size prints, but not tall prints. So my assumption, but this isn't necessarily a fact, is that there just isn't enough room for the Z-hop to compensate and get over the poorly executed infill, thus creating the catching and causing issues for many users that are making tall 3D prints on these machines, or using the slicer in general. Most people have their prints fail because of this, but since I had so much surface area from my base and in conjunction with my third-party PEO or whatever style build plate, it was holding on for dear life. And rather than falling off the build plate, it stood its ground, and the stem just took the brunt of the catching and then violently snaps back into position from the plastic's deflection. It was impressive, but also pretty scary because it was a loud ordeal, and not the type of sounds you want to hear coming from your 3D printer. Now, how do we fix this? Well, we simply have to find an infill that works for our model that doesn't intersect itself. Gyroid was recommended on the forum that I was learning from, so that's what I went with. I lowered the infill density from 15 to 8% because the gyroid seems to be much more dense compared to the cubic. Then I let it go, which brings us to where I am actually writing the script now, so I guess I'll see you in a bit. So here is the newly printed model, completely done. It's kind of hard to tell based on, I don't know if the video is coming out better than what the viewfinder is showing, but it's pretty dark. So the only technical issue is that there is some banding here. You can kind of see it in the light. And this is where the ends of the, it's hard to show this. I'll just pull it off and then we'll talk about it. Okay, so here is the print removal. I believe the last one was firm, but not super difficult. Let's see if this one's the same way. Yep. Alright. So that could have probably ended badly if it hit the wrong thing. It might have, snapped off. But this was pretty strong based on the, what's it called? The printer video that I took off the SD card. So yeah, there is some banding here. I don't know if you can see it. It's probably not going to focus properly. But there's some banding that happens around here, and it's because of something to do with how it reacts to the, the spokes or whatever these are that you want to call these, the struts, the supports. It's just how it reacts, but it's only a minor issue. It'll be functional completely, and I don't know. It's not super pretty, but it's functional. So let's see how well it functions. So here is the other stand that I used for the other video. So as you can see, this one is not great for typical use because it can very easily be tipped over, but for displaying and pictures and mainly one-time uses or occasional uses, this would work pretty decently. This one is meant for people who want to use this a little more frequently. So it sits pretty well. Unfortunately, it is a little tippy in the back way. I could put a little bit of support in the back here, especially since I'm already printing upwards. I might add that in another separate version, but yeah, it's pretty easy to take these on and off, and the only reason why it's really tippy is because I don't have a weighted base for this, which I would love some suggestions on how to weigh down 3D prints with as little material as possible, because I just cannot find out. And for the most part, I haven't found. It's been a long time since I searched, but I don't think I could find a whole lot on weighing down 3D prints for the most part. At least not actually effectively. So yeah, this works. I might add a little bit of triangle on another separate model, and these will be available on my Maker World. Let me show off the model a bit. God, this picture is kind of dark. I don't know why. I don't know if it's just my viewing angle or what. So, in hindsight as well, if I really wanted to make this model quote-unquote perfect, what I would need to do is, since these headphones are so bulky, even though for displaying, I think it looks pretty good with the slight slant, if I wanted them to hang straight down, this back wall would have to come forward and this whole thing would have to come out just a bit so that it would properly hold the band in place, but there would be enough room to support the backside here to, have room to hang straight down. So just another suggestion if you are building your own version of this model. But yeah. Alright, so if you found this video informational or entertaining in any way, please leave a like. We normally do music and 3D printing related stuff around here. This was sort of a combination of that. So if that sounds good, please consider subscribing. I have affiliate links to some good 3D printing stuff down in the description, and I might put some links to these headphones and this other affordable pair that I just got recently that I'm quite enjoying. Using those links really helps me out because I don't make a whole lot of money. So using those links, if you don't even have to buy what's actually linked, you can, if you use that same instance of Amazon in the tab, it should get me a little bit that can help me out as well. Someone recently bought a Sonicake Valois guitar pedal, which was my 5th ever made video. So I thank you to whoever made that purchase, because it actually got me a whole $1. Usually it's very small, and that was off of a $60 purchase, but that was a big win in terms of affiliate link earning, and I very much appreciate that. So that's all I have to say for now. So I'm gonna say bye-bye.